So welcome to Thursday of week 6. We did a little review before hitting record. And now we're going to talk about finding all the factors of a number, because that will be useful to us in just a moment. Up at the top in these two kind of brown boxes are lists of divisibility rules. If you are like most math students, then you have familiarity with the top three. Somebody somewhere in your life has taught you that a number is divisible by 2, which we also call even, if its ones digit, the smallest digit, the ones place value place, is 0, 2, 4, 6, or 8. And maybe they said a number is divisible by 5, it's a counting by 5 number if it ends in 0 or 5, the ones digit is 0 or 5. And it's divisible by 10 if it ends in 0. So we could look at numbers like 128 and say, that one's even because it ends in 8. Or we could look at 435 and say that one's a multiple of 5 because it ends in 5, but neither of these is a multiple of 10. And I just switched in my language from divisibility rules to a multiple, but hopefully that makes sense to you. If a number is divisible by 10, it is also a multiple of 10. It's on the tens times tables as you're counting. Everyone with me so far with that review?
Yep.
Okay, there's 4 more rules. For now, let me make them bigger so you can read them better on the Zoom. These are not any harder than the other ones, but for some reason, you often don't get taught them. I see very few students that arrive at LCC having seen these, and I'm not sure why they get skipped. So these 4 rules are I'm trying to do, let's make a green line there. Okay, those rules. A number is divisible by 3 if the sum of its digits is divisible by 3. So looking above, if I wonder, is 128 a number that's divisible by 3? I would add up the digits, which if you've never seen this looks really strange because we're not normally interested in doing that. And if I add them all up, I get 11. Does 3 go into 11?
No.
No, so 3 does not go into 128 either. Let's check the other one. 435. What happens when I add those up? Well, so those add up to 12. Does 3 go into 12?
Yes.
Yes, so 3 also goes into 435. If there is a fraction and one of the numbers, top or bottom, is 435, then maybe that fraction is something that you could divide by 3 top and bottom to reduce it and make it simple. A number is divisible by 6 if both 2 and 3 work, because 6 is 2 times 3. A number is divisible by 4 if when you make a 2-digit number just from its tens and ones place. So in 128, I'm only looking at the 28. I can ignore everything else after that. Does 4 go into 28?
Yes.
Yeah. So 7 times 4 is 28. So 4 goes into 128. And in fact, 4 will go into a number with anything stuck in front of the 28. 728. 1,528, whatever, it'll always work. That's the point of that rule. And lastly, a number is divisible by 9 if the sum of its digits is divisible by 9. So with our 2 example ones, does 9 go into 11? No. Does 9 go into 12? No. So neither 128 nor 435 were divisible by 9. There are other divisibility rules. You might notice we've skipped over 7 and 8 or 11, but those are actually clunky. They are not fast like these, so you would never use them. Let's now find all the factors of 66. And to do this, we're going to make a horseshoe. I'm going to think, what numbers multiply together to get 66? Well, 1 times 66 does. Is 2 a factor of 66?
Yes.
Yes, but 2 times what?
33.
33. And if Vincent, Kayla, or Victoria want to type in chat instead of talk, I'm gonna open the chat. But we can just talk too. We're all here. Okay. Does 3 work as a factor?
Yeah.
Yep, 3 times, whoops, not 11, 22. Does 4 work as a factor?
No.
No. Okay, skip that. Does 5 work as a factor?
No.
No, it doesn't end in 5. Does 6 work as a factor?
Yes.
Yes, 6 times 11. Does 7, you might have to test that on a calculator or try it with long division. No, it doesn't work. Does 8 work? No. Does 9 work? If I add up 6 and 6, I get 12. 9 does not go into 12. Does 10 work? No, it doesn't end in 0. And now I'm back where I was. If there was anything bigger than 10 that worked as a factor, it would already be on this side of the horseshoe, because it would need something small to go with it. So I have now found all the factors of 66. Oh, okay, I'm going to say a common question now is, what about factor trees? Factor trees were fun. I remember factor trees. No one's ever shown me the stupid horseshoe thing before. Well, factor trees answer a different question. If I try and make a factor tree for 66, I certainly can. There's lots of ways to start it. How does somebody want to start it for this example?
6 times 11.
6 times 11, okay. And the 6 is 2 times 3. And if you know how to use factor trees, then you're going to circle all of the leaves. And you're going to wind up making a multiplication sentence involving prime numbers. Does that look familiar for factor trees? Notice the factor tree didn't tell me all of the factors. 22 was not on it. Even 1 wasn't on it, although that one's we can just always think of. So factor trees can get the primes, but they don't tell you all the factors. And sometimes that's the right question to ask. So we're not using factor trees because they have their uses, but this is not one of their uses. Okay, tell me what to write now that you've seen this. For 24, 1 works because 1 always works. What's the next thing I write?
Well, 6 times 4.
We're just counting down. After 1 comes 2.
So yes, 2.
2 does work with,
Well,
Yeah.
okay. Zoomy is help Isaiah, not Isaiah,
Yeah.
Anthony. He's feeling lonely here.
Mhm.
Okay, 2 works. Oh, I forgot to put this in chat, didn't I? That will get more people here. Okay. How about 3? Does 3 work? Yeah, 3 works.
So,
2 and 4 is 6, 3 goes into 6.
yeah.
So I'm gonna actually, oops, erase that nice 4 he made.
You're just, there it is.
There it is. 4 we will write down, but first we want the 3. So 3 times what?
Seven.
3 times 7 is 21. 8 works, okay. 4,
Six.
6, yeah. Does 5 work? No, and then we're back to 6. We've made it all the way around the horseshoe. Everyone happy with that?
Yep.
Do you want me to do a third one?
Sure with it.
Sure, okay. So 60. Okay, well, 1 and 60, it always starts boring.
2 and 30.
2 and 30. Yes, thank you. Does 4 work? Does 6 go into 40? Sure. How about 5?
Yes.
Okay, 6,
Wait, 10.
7. No, it's not going to. 8, no. 9, 6 plus 0 is 6. 9 doesn't go into that. And then we're back to 10. So, ta-da. There's a few classic cases of when to use this other than fraction simplification or what we're about to do with polynomials. The most famous is called the band problem. So if you have 60 people in a marching band, how can you put them in lines where all the lines have the same number of people? And this tells you that you could have either one line of 60 or 60 lines of 1, somebody single file, or just one long side by side thing. You could have 2 rows of 30 or 30 rows of 2. You could have 3 rows of 20 or 20 rows of 3, and so on. So that's the classic example of what you would actually use this for, but we don't care about that. We are studying for the GED, not marching band dynamics. Okay. So we're going to use that with this kind of logic puzzle. What are 2 numbers that add to 7 but multiply to 6? If you can think of them, it's okay just to spoil it for everyone in this first one. Call it out loud or type it in chat.
I'm not confident in this, but 3 and 4.
3 and 4. 3 and 4 do add to 7. When I multiply 3 and 4, though, I get 12, not 6.
Yeah.
But thank you for being brave and sharing.
Oh, 6 and 1.
6 and 1.
Yeah.
If you said 1 and 6, that would also work. If you wanted to be very methodical about this, you could do the same thing we just did. 1, 6, 2, 3. Does 4 work? No. Does 5 work? No. So that's all the different ways to get 6. So which of those add to 7? Moving on. What about 2 numbers that add to 13, but multiply to 36? So 1 and 36 work as a multiplying, but they don't add to 13. How about with 2?
Yes.
What's half of 36?
9 and 4.
Yeah. So 3, 12, 4, 9, and yes, she was right. 9 and 4 is the row that adds to 36. So this one. Everyone happy so far?
Mm-hmm.
I am going to try and make it tricky by tossing in a negative. So what are now two numbers that add to negative 25, but multiply to 144? So since they add to something negative, at least one of them has to be negative. Since they multiply to something positive, then they both have to be negative. So this is a -1 and a -144. That obviously doesn't work. -2, -72. No, that doesn't add to -25. What else might work?
-48 or -48. For that factor.
This one, okay. So not wrong some, but we're getting closer. Does 4 work? Sure. Still too big a sum.
-9 and -16.
-9 and -16. Ta-da, there we go. And the last possible combination. Now we have two numbers that add to 16, but multiply to 36. And if you look at our 36 column, that's not going to work. But one of these is, if one of them is negative, then it might work. And I think this should say -36. One moment, edit my text box. Only one of them is negative. There, okay. So I'm gonna make my list, but we have to be aware the negative sign might be on the other side. It's nine. So none of those add up right. What if we shift the negative signs around?
Two and 18.
Not 2 and 18 both positive though. Which one has to be negative?
-2.
The 2, right? Everyone okay there?
Yeah.
So I hope you thought this was really fun. Because this is the secret to doing the next math topic. So I'm gonna zoom out a little and scroll around. So I'm going to review using a box with 4 corners how multiplying worked. And I'm using, as I mentioned last time, this very visual method, not because it's everyone's favorite, most people like FOIL better, but to think about how it works backwards, having a diagram is often easier. We took 2x plus 3 and put it here, 2x plus 3. And we took another 2x plus 3. Put it going down the other side, 2x plus 3. And then wherever things multiplied, 2x times 2x is 4x squared. 2x times 3 is 6x. And so on. Everyone okay with that process from Tuesday? So what we're wondering is how could you ever do that backwards?
I know, right?
I am drawing a rectangle, but this is a completely different rectangle. This rectangle doesn't have four corners. That's the main difference. And we're also starting on the inside and working our way outside. So I'm given a polynomial. 4x squared plus 12x plus 9. I've never seen this one before. Someone just gave it to me. And they said, what two smaller polynomials, what binomials multiply together to get that? And there's a process. And the process won't fail me. First, I turn this into one of those logic puzzles we just did. I say the middle thing, if I call it the whole polynomial a times x squared plus b times x plus c, then what's this middle thing, the number next to the plane x? So that I'm saying is 12 in my example. So I want two numbers that add to 12. Let me pick a different color. Everyone see where the 12 is coming from? And then I take the other two numbers and I multiply them together. So 4 times 9 is 36. And that's what I want my logic puzzle two numbers to multiply to. And of course, one thing I should look at right away is, does 4 times 9 work? Does that add up to 12?
Just 4 plus 9? Oh, yes.
No, 4 plus 9 does not.
What are you talking? What'd you just say?
So the 4 times 9 did multiply to 36. Does it also add up to 12? No, the 4 plus 9 is 13. So we're close, but we're not there. Sometimes it's that easy. Okay, so what new numbers work? And I imagine that I have a rectangle and the area is 36, like length times width. But I don't know what the length and width are. Whatever they are, I have to be able to add them together. Let's go back to here. This edge, the length plus this edge, the width. And they should add up to 12 in this case. So I'm thinking about an area shading in an area. And I'm also thinking about adding up two edges together. Maybe that all helps you, maybe it doesn't. Okay. So I notice 6 and 6 work. They multiply to 36. And they add up to 12. So 6 and 6 work. So I'm going to take my original thing I had way up here and break it apart. Where there was a 12x, since 12 is 6 plus 6, then I am going to break it apart into 6x plus 6x. So let me steal this and put it down where we're going, so you can see that thing. So this is weird. We're only doing this because you trust me that there is some process here that is worth learning. Why would you possibly know to do this? But has everyone followed me along okay?
Yeah.
Okay, we'll do a bunch of these. So it's okay to be shaky. I take the 12 and I break it apart into 6 plus 6. Then I can factor everything I can from the first two terms. So from these red terms, there's a 2 and an X in both of them, so I'll put that in front. What's left from the first term, another X. From the second term, a 3. Everyone okay with how I got from here to there? I thought separately, just for the plain number, what's the biggest plain number in both of these? And 2 is the greatest common factor. And then how many X's are in both of them? Well, only one X is in both of them. So I put that there also. And then I had to do division. If I do 4x squared over 2x, what was left? Just one of the x's, so that one there. Or if I do 6x over 2x, what's left over? Just a 3. So that goes there. Does that help?
A little bit.
A little bit.
Yeah, a little bit.
Hopefully with more repetition of this, it will make more sense as we go. Okay. Then I do exactly the same from the other terms. I look at the blue ones. And I say, what's the same in both of those? What's the biggest number that goes into both 6 and 9?
6.
6 is not a factor of 9.
Oh, sorry.
3, so that will put front. There's no x's common to both because 9 has no x's at all. And then what do I multiply by to get to what I needed? I want to get to 6x, so I need 2 more x. I want to get to 9, so I need another 3. Or think about doing the division. If I did a division by 3 on each of these, what would be left over? A 2x and a 3. If you notice, it will always be true that the thing that you have now in 2 different places in parentheses is the same. That's the magic of this process. So since I have something times 2x plus 3 plus something else times 2x plus 3, I can take those things and put them together. That's what the next step is. So let me scroll down a little. I took a 2x plus 3 from here and here and put it there. And the green one was the one that was always there already. Okay, let's do a whole bunch of these, because this is kind of long and confusing. It's like riding a bike. Once it clicks, it will be okay. But the first time you see it, it is imposing and scary.
Yeah. Yeah. Larry, Larry. He's such a good boy. Okay.
So 20x squared plus 37x plus 15. Everyone okay with that? Multiple?
Yeah.
So I'm just reading up here, 20x squared plus 37x plus 15. So I had an area of my rectangle I'm looking for that was the first part times the last part. So what's 20 times 15? Well, 2 times 15 is 30, and there's an extra 0 from 20.
I love my dog.
So I get 300. So I'm looking for a length and a width. That when I multiply them together, I get 300. Everyone okay with that?
Yeah.
And when I add them, I add the 2 sides, then I get that middle number. So what I want is 1. Length plus width equals 37. Oops. So that's what the middle number of my polynomial was. So what are two numbers that multiply to 300 but add up to 37? Well, 30 times 10 is 300, but that doesn't add up the right way.
Oh, right here, thanks.
So 1 times 300, no. 2 times 150, no. 3 times 100, no. It's 4 work, sure, 75, no. 5 times 60, no. Well, slowly I'm getting closer. 6 times 50, does 7 go into 300? No, 8.
Oh, I was trying to find factors of 37.
No, we want the factors of 300. We're multiplying to get 300. And then we're checking what they add up to. 9, 10 is 30. 11. It's 12 work. 25. Oh, there we go. Those add up to 37. Hooray. So see why we had to do this game of which things add up, or what are all the factors of a number, not just the prime ones. So my length and width are 12 and 25. Now, I'm not saying you want to do this for fun in the evening, but everyone's following how I did that.
Sorry, say that again.
Everyone can follow and do this. Hopefully the ones they would give you as homework don't have such big numbers like 300. But the process is okay. I don't do this for fun either. I never sit down after the kids are in bed and say, you know, honey, I think I'm going to factor some polynomials. But that's okay. So I'm gonna break this apart using those two numbers. We had a 12 and a 25. And at this point, I can kind of turn my brain off. The rest is on autopilot because I know this process and it always works. What's the biggest thing that's in common with the 20x squared and the 12x? What's the biggest amount of the plain number for 20 and 12? Hello.
I'm Mel from the Fair Housing Council. I'm talking with Shauna today.
Shauna.
Your teacher? What's her name again?
I don't know. Are you in the wrong room?
No, this is the Renwell class. No? Oh my gosh.
That's okay. Nice to meet you. Okay, 20 and 12. What's the biggest number in common?
4.
4. And how many x's do both of them have?
Me together?
Or what's the biggest amount of x's that are in common for both of them? They both have at least that many.
They have at least one X.
At least one x. And notice that part we can stop thinking about soon. These first two numbers will always have one x to share. Because there'll always be an x squared and a plain x. So 4x something plus something. So 4x times what is 20x squared? How much more plain number do I need? Multiplying.
5.
5, 4 times 5 is 20, and I need one more x to get x squared. Everyone okay with that step? I'm not gonna write more put a thumbs up in chat or ask a question out loud or something like that.
Tree. Tree, teacher. Tree.
3, yes, the next one
Yeah.
will be, I don't wanna move on until Vincent and Kayla and Victoria say they're here and okay.
I hear it, okay.
Okay.
Yeah.
So yes, the next one is 3, and I don't need any more X's. I have an X already, that's all 12X gets. There we go. Now this is starting to feel kind of magic. What's the biggest thing in 25X plus 15? That's my next part. Whoa, that's a giant thing. Let's not write that. Okay. There we go. So what's the biggest number part in common to 25 and 15?
5.
5. And I could think more about X's, but there's no X's in 15, so all I have is a 5. So I need 5 more X's. 5 times 5 is 25.
And
And-
3.
Oh my goodness, they match 5X plus 3 in both parts. Who would have thought of that? Our process is working. So then I group together, maybe a different color. The 4 and the plus 5. So I have that times a 5X plus 3. And I have that times a 5X plus 3. So now I have a factored thing. I can put a box around it. I can make a better box. In fact, I can just cheat and make a box this way. Come on, show me my menu. Ooh, okay. Yay, okay. Everyone happy with our first factoring problem?
Yeah.
This is a long process, especially with big numbers like 337, but it's a reliable process. When I was looking at what two numbers multiplied to get this or added to get that, I would eventually find it. It might take a while, but there was nothing really tricky about this. Especially if I had a calculator, I could just test. 300 divided by 7, nope, doesn't work. 300 divided by 8, nope, doesn't work. 300 divided by 9, nope, doesn't work, so on. So I would eventually find this. And once I found it and I broke the 37 up into the two parts of length and width, then all I have to do is this little factoring part, which is right now probably new and scary. But again, it's like riding a bicycle. You will get good at this when you spend an hour doing homework. And I wish I could avoid having to invest that hour, but that's just kind of how things are. This is something you have to do yourself, like pottery or Aikido, and then you know it and can do it more. Okay, now we have a negative number, panic. Okay. The good thing is that we don't have any fractions or decimals. This is one of those things that the GED cares about the process and isn't going to make you needlessly slow down with fractions and decimals. So if you hate fractions and decimals, you will eventually like this kind of problem because it doesn't have those. So I again have a length and a width. I'm not sure what they are. What are they going to multiply together to get? 6 times 5 is 30. Oh, that's a lot smaller than 300. Hooray. So my area is 30. Length times width is 30. And what do they add up to? What's the
11.
middle number in my polynomial?
Oh, 5. They have to add up to the middle
They
number.
have to add up to the middle number.
So
Before it
five.
was 37.
Oh, I'm sorry, I'm looking wrong, so 13.
Not quite. Not just any 13.
Negative 13.
Negative 13. So we have adding up to a negative number, multiplying to a positive number. One of these things is going to be negative and one of them is positive. Everyone with me so far?
Mhm.
Okay, well, that's just like work. That's okay, I can do work. So it could be a 1 times a 30. Does that add up to 13 if either of them is negative? No. 2 and a 15?
Negative.
Yeah, right there. I found it. Negative 15 and 2. Oh, wait, no, I'm sorry. That would multiply to be negative 30, so that doesn't work. Okay, never mind. Okay, mistake. I'll keep going. Negative 3. And negative 10. There we go. Now I found it. Two things that add up to positive 30. And I multiply to positive 30 and add up to negative 13. Sorry, I confused you.
I understand it, but yeah, at the same time.
You can understand it and hate it. That is fine. Okay, so negative 3 and 10. So I will break apart my negative 13 to be 6x squared minus 3x minus 10x plus 5. Everyone okay with that?
Yeah,
I took a negative 13 and I said the box tells me how to split it up into two different numbers. Okay, now I do my factoring. 6 and 3, 3 is the biggest thing, and there's always an x the first time. What do I need? For here, I need a 2 and another x, so 2x. 3 times 2 is 6, x times x is x squared, and a minus 1.
Made you get the 3x to begin with again?
Because I looked and 3 was the biggest thing for 3 and 6. That's the biggest factor common to both of them.
Okay.
And how many x's did they both have? They both had at least one. Now. I can take from a negative 10 and a 5. I can take 5 out of there. Oh, that 5 looks kind of flat. And then what do I have? A negative 5 times 2x makes negative 10x. A negative 5 times a negative 1 makes positive 5. And oh my goodness, look at that. The 2x minus 1 is the same in both parts. So I can take my 3x from the first part. And I can take my minus 5 from over there. And say that's the other part of my two polynomials.
So would that be the answer then? Is
That is the answer.
3x negative 5 and 2x negative 1?
Yeah,
So are there gonna be any ones where you end up with the numbers that are in the parentheses are not the same?
no, because the process always works.
Oh,
So again, this isn't what we do for entertainment, but there's no fractions, there's no decimals. It's a reliable process. You can feel good that once you practice this a bunch and get smooth at it, it is a kind of not 3 points on the test, but reliable points on the test. That's the next best.
typically like this.
You like decimals and like when they reward you with extra points for playing with decimals, then oh well. Okay, should we do another one?
Yep.
Okay, Tell me where to start. Who remembers?
We need length times width.
Length times width. Okay, a length, oops. And, okay, a length and a width. What are they going to multiply by? Multiply together to be? It's the first plane
30.
number and the last plane number.
Wow, I'm looking at the wrong one, I'm sorry.
So- 3 times -5,
So negative 15.
yeah. -15, oh, okay.
And then they need to add together, make 14.
14, right, and then length plus width equals 14. So what multiplies to get -15? You could have -1 and 15. You could have -3 and 5. You could have, oh, but wait. Do you see it?
-3 and 5.
Those add up to 2. We want to add up to 14.
Oh, right, so if you have 15, take away 1, so
Yeah.
-1 and 15 is 14.
One of these is -1 and the other one is 15. They add up to -14, that's what we wanted. I'm sorry, they add up to +14, that's what we wanted. And they multiply to -15, that's what we wanted. Everyone okay so far?
Mhm.
So then I'm going to take my equation, which no longer has room under it to write because of my commentary. And I'm going to take this 14x and split it up with the -1 and the 15. So I will instead have 3x squared minus 1x plus 15x minus 5. Everyone okay with that line?
Mhm.
Okay, what's the biggest thing in common with 3x squared minus 1x?
3.
Oh, you're overly ambitious.
Hmm.
There's no 3 in this part.
You're right.
X,
It's just an x, that's all there is in common. How about the other part over here?
5,
There's 5 in both 15 and -5. And lo and behold, 3x minus 1 appears in both places. The process works. You should feel good at this part, right? Now, what we haven't actually done is check our work. I promised you I would and I forgot, so we'll go back and do it. So then the x and the +5 come together. And the 3x minus 1. And I actually draw a box this time. There we go. Okay. Let's check this with FOIL. So the first x and 3x squared. O is for outside. So the outside is the x and the -1. That will give me a minus x. Inside, 5 and 3x, 15. X, not plain 15, 15x. And then the last. So the 5 and the -1 are the last of each parentheses, and we get a -5. Does this look familiar? It's the same as this line. And then what do? You would have to say, oh, my minus X and my 15X have X's in common. I should take these like terms, as somebody decided to call them, and squish them together. And I'm back where I started. So yes, it does work. Okay, your brain might feel like you're being bludgeoned mentally with hot pasta, but let's do one more. (20x squared minus 48x minus 5). Where do I start?
Like times width.
Anthony again says length times width. Okay, what do they multiply to be?
-100.
Everyone see why the area they multiply is -100?
20 times -5.
As it's the first thing times the last thing, 20 times -5. And then if I add up length plus width,
It's 15. Oh, I'm sorry. -48.
and -48, because that's the middle one. Okay, all the zoomies okay?
Yeah. I still calculate, teacher.
Okay. So what multiplies to get to 100? Let's see, we could do 1 times 100, that's not gonna add up to -48 or -100. Could do 2 times -50. Oh, we're there. Two and -50 add up to -48. So I will take my original thing. And break it apart with the -48 turning into a 2 and a -50. By the way, does it matter if I write the 2 first or the -50 first?
No.
No, can't go wrong. Okay, I am staring at the first two items. 20x squared plus 2x. What do I write in front of the parentheses that I'm about to make?
10.
10. 10 is too big, there's no 10 in 2.
Oh,
Thinking 10 is the right thing to be thinking.
maybe two first.
2, yeah, and an x.
10. 1.
Everyone okay with that half?
yeah.
And now we have this half, -50x minus 5.
And 5. 5. 5
So
and 10.
I'm actually gonna do a -5, because there's a minus in both of them. So then I get a +10, because minus times positive is minus
This one.
x. And +1. And the 10x plus 1 is the same in both of them. So I get the 2x minus 5, the things in front come together. Thing in front, thing in front. come together. And the 10x plus 1. Should I FOIL this one to check?
Sure.
Oh, okay. Gonna look pretty familiar. Check with FOIL. So first, the first part's 2x and 10x. 20x squared. Then the second part, the outside, 2x and a positive 1. So positive 2x. Then the inside part. Negative 5 times 10x, negative 50x. And the last parts, so the last here, negative 5, the last part of that, plus 1, negative 5. What are my like terms? Well, these two both have an x. Nothing else is the same because this is the only x squared term. And that's the only plain number. And 2x minus 50x is minus 48x. Okay, ta-da. So when we multiplied polynomials, there were some secret patterns that the book calls special products. And the last thing to talk about would be those. But as before, the book does a very good job explaining these. And some people, it kind of spoils the Agatha Christie mystery if I just show you all the patterns. Especially if you haven't done the homework for the multiplying polynomial chapter where you find the patterns yourself. But one pattern we did see, so I will spoil it, is we did see a pattern that we called a plus b times a minus b
Equals a squared negative b squared.
a squared minus b squared. And I'm hesitant to write this because we were just using a and b to mean certain things for the length width procedure. But this is what your book has, so I'm going to write it also. So this was something like 4x minus 3 or plus 3 times 4x minus 3. And when you FOIL it, the first is the a squared, 4x times 4x is 16x squared. Then the inside part, the 3 and the 4x gives you a positive 12x. And the outside part, the 4x and the minus 3 gives you a negative 12x. And those are always going to be the same, but one is positive and one is negative.
So they cancel.
So they cancel out. And all you have left in the FOIL is the L, the last part. So a positive b times a negative b is a negative b squared. A positive 3 times a negative 3 is a negative 9. So if you were to look at this polynomial and try and do the procedure we just did, there's no middle term with an x. It still works fine. We want a length times width. That's 16 times 9. So what's 16 times 9? 9 times 6 is 54.
144. 144.
And we want the length and width to add up to something. In this case, it's 0, right? There's a 0x hiding here.
Isn't that -9, so it'd be -40?
Yes, it is, thank you. So we can still do the same thing we did before. What are two numbers that multiply to -144 but add up to 0? Well, 12 and -12. So then I will break apart. My 16x² minus 9 to be 16x² plus 12x minus 12x minus 9. See how this is exactly the same game we just did 4 times above? The fact that there was nothing here doesn't slow me down at all. And then what's the same of 16 and 12? That's 4 and an x. And what's the same of 12x and a 9? That looks like a -3. With a plus there. And then the first part before the parentheses comes together, the 4x and the -3. And ta-da. So my process I taught you earlier always works, even with these special product cases. But they're special, they're a shortcut. If you happen to see something squared -9 and think, oh, 9's a perfect square, that's 3 squared, then I can use my little formula above and save some time. So is it worth going into lots of class time with the special cases? I don't think so, because the general process always works. But if you like the special cases, great, you can feel strong and powerful and smart learning some shortcuts. Okay, that was a whole lot. And we're way past 7. Should we take a brain break?
Take it easy, restroom.
Yes, please.
Okay, see you in a few minutes. I will pause the recording.
Well, this exercise definitely showed me that my multiplication table.
Recording. We're about to have it be your turn to do some of these, but before I set you loose, I want to go through the lecture style that the textbook uses. Both because it's nice to have a second opinion and hear different words about how things work. And because if you're a visual person, then the normal thing will happen where this sort of makes sense now when you're watching me, and then you get home to do some homework and it's like your brain is totally different and what happened. Some of you will look at the recording and review the length times width method because that's what the recording has. But others of you will be more visual than auditory, and you'll look at the textbook and say, what did the textbook do? And I want to do that with you so that it makes a little more sense when you see it. Sound good? So it's talking about factoring. It says, remember, let me make it bigger. Remember how to multiply? Sure, we know how to multiply. And remember how to take these two little ones we call binomials and make them into a bigger type of polynomial that we call a trinomial because it has 3 parts. And they mention that there's a product with the AB and a sum of the A plus B. That's the length times width, having a multiplying and adding kind of thing going on. They start out by saying, well, it's simpler if the number by x squared is just a one, it looks like it's missing, one x squared. Because then it's always one times this other number, in this case 12. So I don't really even have to think about multiplying to get the area of the rectangle at the beginning. So we want two numbers that multiply to 12 and add to 8. Well, 6 and 2 will work, and they show you that process, and so on. They do one with a negative. They do one with a positive and a negative, just to get through all the different combinations of positive to negative. They also do something harder than the GED in this example 5. What if there's a y also? And just like the x's go down in exponent, 2, 1, and no x's, the y's are the opposite pattern. No y's, 1y, y squared. So don't worry about the ones with the y if you don't want to. And then they test to do it. And then they say, well, let's do some more of those. And they're saying you could just do some trial and error of which things multiply to 2 times -3 is -6, and so on. I'm not teaching you a trial and error method because we have a good reliable method, but if you want to look at this, you can. And then they say, here's more things to practice with. So not too exciting. Okay. Anyway, back on our whiteboard, we have 3 problems. I think 20 is the easiest because everything is positive. I would have put it before 11 in the book if I made the book. So work on those, talk to each other, pretend this is a midterm, you know how to interact with things. And see if you can get these 3 done. And we only have Anthony here for in class, so he's just gonna talk at the D10. And it occurs to me, if you are in Zoom, you don't know what this looks like, so I'm going to join our Zoom with my phone, because I am that exciting. Um, Why isn't my phone showing up? Yeah?
Yeah.
It is?
Yeah.
Okay, now you can see. So you can see there's a big overhead projector where the screen is projected. And then there's a smaller screen to the left of it that has the Zoom and your little, what do you want to call them? Not family, if you suppose the Brady Bunch, the Brady Bunch boxes of everyone are on this little stripe at the top of it. And Anthony is sitting there, right? So it's not like when you talk in Zoom, your face is 5 feet tall on the main screen. You're this little box, so don't feel embarrassed about talking. We'll try it. Zoom Sue, wave and say hi to us.
Hi.
You see her little box on the smaller screen, right? So don't feel embarrassed if you're talking to Anthony. It's not like you are the giant Wizard of Oz face looming down at him. It's not that big or that loud. Okay, I'm gonna leave my Zoom meeting. Okay, so work together. See if with 5 of you, you can figure these out. I see some people are up high. I'm gonna be rude and bring all your arrows down to.
Well, I'm up high, cause I'm looking at the
Are you looking at the,
examples.
okay, well, scroll back up. If you're allowed to look at the examples. Do you want me to stop sharing my screen and recording?
Oh, you're fine. Don't mind, I'm not that lonely.
That could be more impressive to the people who aren't here today. It's just like, ow, the answers.
Oh, yeah, well, I already, if that's the case, then I already embarrassed myself earlier on your recording, so.
So. I think I've made more mistakes than anyone else tonight. Maybe. Everyone working by themselves, you're not cooperating.
Yeah, great.
Question, what question? Question 20?
No, I'm not really. Yes, there's still that. No.
What is your question?
I asked in the group that what they do in the question, which between question 20 or 25.
Why don't you all start with 20? I think that's the easiest one.
Okay. That anyone gets same at me or not? I start with 2 and 6.
Let's make that one long thing without wraparound. There we go.
Yeah.
Okay, now keep talking.
Anyone have question or want to guess?
So the first number was 1 by the x squared, the last number was 12. 1 times 12 was 12. So your two numbers are 2 and 6, which do multiply to 12, and they add up to 8 in the middle. So that looks great. Now we see the second advantage. If the first letter, if the A area, right, the number in front of the x squared is 1, like in this case, actually all three of these, then it makes that first bit of factoring easier. What's the same of x squared plus 2x? It's only the x, because there's never a number there. It's only just the x. Let me say that again, but actually right on the board, because I think that will make it much clearer. If there is nothing here, then there will never be any number there.
But you would still put the X, right?
You still put the X, but you never have to worry about what goes with the X. There's always an X and there's never anything else.
Would it be wrong if you put a 1X?
No, you could put a 1X, that's fine. Okay, you're on a roll, keep going.
So now. It should. Be.
Vince is going backwards. You want to be factoring, not multiplying. That's correct, but not what we want.
That's so small.
Not so small. Oh, it's kind of bizarre. I use 36.
Sure. Shut up.
You are racing to type the correct thing.
Wow. Good job, team.
Okay, everyone happy with 20?
Yep.
Okay, 11 is a little trickier, because there's a negative, there's okay, two negatives. You want things that multiply to negative 12 and add to negative 1. I'm gonna start by just copying this one. So you can edit the numbers. Oops. Not have to retype it. What are you thinking about for the two numbers?
One times -12 is -12. And the middle number is gonna be -1.
You need two numbers that add up to -1. And a 1 and a -12, or a -1 and a +12, those are too far away from each other. You need numbers right next to each other, so that when you add them up, you get -1. Do you see why when you add two things, if you were to get -1, you'd have to have consecutive numbers, except that one's negative and one's positive. 7 plus -8.
I I think between 5 and 6 maybe. Can or cannot. I'm not sure.
Like 30, those are too big.
Isn't it negative?
It is.
No, I mean minus 6 and the 5 is the positive and negative together. Let me try to do that.
Change the question marks, right? Where I
I
have question,
mean
put the numbers there.
um
But then
I
five
mean this
times
teacher.
6. 5 times 6 is 30. We don't want -30, we want -12.
Oh, maybe positive, negative.
Yes, 3 and 4 work. So change the 5 and 6 to a 3 and 4 with one of them negative.
Can we do this?
You can edit it, yeah. Just double click on the text box. You can change the numbers. You don't have to type it all over. Double click on it real fast, and then you can change the 5 and the 6 to a 3 and a 4.
Does not 12 need to be negative too?
Yes, and the 12 should be negative. Almost, that's gonna be +1, you want -1, so you want the 4, the bigger one, to be the negative of the two things.
Oops. Type like a dinosaur.
Almost, but now you have the 4 positive, you still want it to overall be -1.
Wait, so it's +3, -4?
Yep,
Oh,
because then they multiply to -12. And they add to -1, and that's what you want. See how that fits with the very top one? +3 -4 overall is a -x.
Oh,
And 3 times 4 with a negative is 12.
right.
Okay, now you do the factory part, x squared and a 3x. As we mentioned before, that has an x in common. And never more than that, because there's no number in front of the x squared, so that makes it simpler. Yeah, no, you're right, X and then X plus something.
I I think negative, teacher. How can I say negative? Negative 1. Negative.
It's gonna be an X plus 3, right, because you have a 3.
Well, I was trying to hear what she was saying, so I was looking. I was like,
Where is the -1 presumed? So which -1 are you talking about? We have that there is a. Whoops, sorry, go away, so then, we have that there is -1 here, and we got it
Oh,
with 3 minus 4. Cause if you go up 3 and then down 4 on the number line, you wind up at -1.
you're right, teacher.
Okay, so x plus 3, that's the first two parts. What comes out of -4 and -12? What do both of those have in common?
3. -3 times -4 is -1.
Yeah, right, but what's in common is the -4.
Oh.
Let me finish the line above before assume Sook. Oops. There's more. Okay, now it should make sense. Happy there? So it's the same process as 20, it just looks harder because of the negatives messing us up. So I mentioned the metaphor of riding a bicycle a few times tonight already, so this is like that. Once you've done it for a while, you'll notice these things, but will go faster, but unfortunately, I can't do anything to save you that time. You just have to do some homework.
Yeah, no, just right, my shoelaces are caught in spokes, so.
25 should be easier than 11. It's all positives. This should be back like number 20. And it is time to stop though, it's 7:50. Okay, so homework is a big deal this weekend, because if you get enough exposure to these, and they start making more sense in your brain, right now they probably don't, then what we do next week will make more sense when I'm dancing around on the board in front of you. If you are still struggling with this making the first amount of sense, then it will slow down what we're doing next time. Which will mean if lots of people don't get homework done this week, then I will just do more of this on Tuesday, because it's not going to work to move on to the next topic. And we're not in that much of a rush. But if you can get lots of homework done this weekend, then we can move on to the next topic sooner next week. And that will give us a time at the end of the term to do more like practice finals things, right? The sooner we get done with new material, the more we can say, okay, now it's like, you know, Tuesday of week 9, and we just finished all the new stuff, so we have a whole week and a day to just do practice finals, things like that. So that's the ideal, but if you don't have time for homework this weekend, we'll do more of this and it'll just slow us down a little and we'll be okay.
David, I would like to ask about question the midterm that would you like me to send about the detail when we do about the class on the last time or not, like a paperwork?
No, I don't need to see the paperwork for the midterm.
Oh,
You
okay.
learned on the midterm what you needed to study and what you were very good at already, and that was the purpose of it.
Not the only one that wanted
Yeah.
it, great.
So,
Thank
no,
you very much.
if you want me to give you a midterm and grade it, I certainly can, but it doesn't do anything.
No, I think it's just more or less seen it on the grade book. That way it's easier to just. Take a snippet, send it to my boss, my HR department.
If it would make them happy at this point, then I certainly can.
That's why I was just wondering if like even as a group grade, you know, whatever we did on the whiteboard, if that was our column was to get graded or something.
Your column was all right, but that was partly because I wasn't letting you go on until I looked at it, so, yeah. You have to tell your boss that much, yeah.
Well, I did not tell him, hey, look, I got an A.
Okay, thank you, everybody. If you want more
Okay.
Zoom office hour time this weekend, let me know. My kid has no gym meet, so I am in town this weekend. If you are doing homework Friday night, Saturday night, Sunday night, you can annoy my wife, say, I need to steal David for an hour, do math and so.
Well, probably gonna be.
Does your son do gymnastics?
My son does gymnastics, yes. Do you want to see a
Where?
video? I'll turn it on.
Where at? Where does he do gym at?
Uh,